All right, so let's look at level of detail in Tableau to see both how we can change the level of detail in a particular table, but also how we can kind of do some introspection, which means look into what Tableau is doing and figure out what data are used to represent or calculate a particular value and how that changes as we move between levels of detail. Again, this is a stepping stone lesson. We're trying to get to visualizations, but to do that, we need to build some confidence in kind of what Tableau is doing and how it's doing it. So let's get started. So we're going to use our world indicators data set again, same one we've been using, and as we've seen, everything is normal. So we're just going to try to create what we had been seeing in a previous video. So here's what I'm going to do. First, I'm going to calculate a new field, and this is just to make the numbers a little bit easier, but it's also to show how we calculate fields. The big idea here is that, yeah, it's great, we have all these variables, but most of the things that we care about in practice out in the real world are derived quantities, meaning they're quantities that have to do with other quantities. So for instance, we might not care about GDP, we might care about GDP per capita so that we can compare across countries that have different population sizes. We might not care about CO2 emissions, we might care about CO2 emissions per capita or per year. Birth rate itself is a derived quantity. It's actually not the number of babies that are born. It might be the number of babies per woman or per woman per woman per year, or it could be a lot of different things. So many of the quantities we care about are things that we have to calculate on our own. So to do that, we're going to go here to our little downward facing triangle button, and we say create calculated field. The other way we could do this is if we're going to do GDP, we're going to do GDP in billions. So the other thing you could do here is right click here and say create calculated field. Both will get you the same thing. We're going to call this GDP in billions, and this is going to be the simplest possible calculated field that we can make. I'm just going to get rid of this real quick to show you how this works. So in these calculated fields, all variables are located within square brackets, and you know that it's identified something good because it turns the font orange. So we're good here, and we'll say divide by, and I'll do 1 billion. So that's 1, 2, 3, 1, 2, 3, 1, 2, 3. Is that right? Hundreds, thousands, billions. Okay. It's like I don't want to get it wrong. Goodness gracious. 3, 3, 3. Okay, good. All right, perfect. It's the hardest things that are the easiest, or vice versa. All right, so we have our value here. And now let's drag this to text. And so now, right off the bat, we have to ask ourselves, what does this represent? So this is the sum of the GDP measured in billions across the entire data set. So this is, as we know from looking at the data set, all countries and all years. So it's kind of a weird quantity, right? And not necessarily a meaningful one. So to make this more meaningful, let's start by dragging region into rows. So this is the sum. Notice this is the aggregation function, the sum of African GDP, Asian GDP, European GDP, and so on across all years in the data set. But again, this may not be what we want, right? Because it's not. We don't know how many years are in the data set, for instance. That seems like a clear, maybe there's 10 years, maybe there's 100 years. We don't know. So let's drag year into the rows shelf as well. So notice now we've got something interesting. We have a particular level of detail. We are at the region year level of detail. This is really, really interesting in the sense that we've now gone from a coarse level of detail, region, to a finer level of detail, year. And in addition, these are actually more meaningful quantities. For instance, the GDP measured in billions of Africa in the year 2000 was 603. That's really, that is a meaningful quantity because it's in 1 year across the entire continent. What was the GDP? We have the same thing for Asia. We have the same thing for Europe, and so on and so on. We could make this even finer level of detail by dragging in country and region into our rows. So now I have, I'm at the original level of detail of the data set. I'm at the region, year, country level of detail. But remember, region kind of drops out here. So I'm at the country, year level of detail, which is really interesting. And the way I can kind of figure out what's going on here, and this is going to become really useful if you're ever in doubt, like this is critically important. If you're ever in doubt about what a particular cell or what data a particular cell, or what data a particular mark on your visualization, what data were used to make that number, all you have to do is the following procedure. So you click on the thing, and then over here we've got this little kind of grid, this grid icon. If you hover over it, says View Data, which is exactly what you would expect. We click the icon itself, and if you go to Full Data, this is the one we want. So right now, in this particular cell, we only had one row in the original data frame that was used to generate this value. And that makes sense because the original level of detail of the data set was the country year. And so we only have one row that's this country in this particular year. And notice it's the entire thing, not just, it gives you the whole row, not just the GDP part. So maybe this will be a little bit more clear if I actually remove country region. So I can reduce the granularity of the view by actually removing this variable from the view. And now we're back to the region year level of detail. And so let's, again, click on our first entry here. Oop. Gosh, I'm on a trackpad, so it's kind of tough. And then we hit View Data again, View Full Data. And so now what we see is, so we're at the region year level of detail, and I have for Africa in year 2000, every single country from Algeria and Angola all the way down to Zambia and Zimbabwe. So all of these rows in the original data set, were used to make this value here. That's what's happening here. So if you're ever in doubt about like, okay, what does that data point represent? What original rows is it combining? All you ever have to do is view data. And it's a great way, if you're spinning out a little bit as you start, especially at the beginning, as you start to get your feet under yourself about how level of detail works in Tableau, if you're ever in doubt, all you need to do is view the data and say, right, okay, so I'm at the year region level of detail, and that means I've aggregated across all countries. Okay, that makes more sense. And in this example, it's actually fairly straightforward. You can be aggregating over a lot of different fields, like, oh, right, I forgot. There's that other field that changes, and I forgot that I was aggregating over that. So the view data is always a helpful way to kind of recenter yourself if things get hairy. So another thing we can do here then is remove the year, and then let's like think. I mean, even if you have to pause the video, make a hypothesis. When we look at the data here, what will we see? You know, what are the actual rows that are comprising this first value? So hopefully you have your hypothesis, and we'll go look at the data. Go to full data here, and what we see is for Africa we have all of our countries, and that's useful, and I'll scroll down. But if I keep scrolling, I have the countries again. And the reason for that is because I've gone from year 2000 to year 2001. And then if I keep scrolling, I have year 2002 and year 2003 and so on. So I have every country in Africa across every year in the data set. All of those have been boiled down via the sum in order to make this single value in the data frame. So again, this is exactly the example that we saw in the static version. This is just how Tableau represents it. If instead we wanted to use a different aggregation function, we would go over here to our GDP here, and our goal is to change this sum. And to do that, we would go to measure, and then instead of using sum, we would use average, or we could use max or min or median or a percentile. Remember, the aggregation function is literally anything that will take a list of numerical values and boil it down to one. So the most common are sum and average. You could also use min and max. You could use count. That's actually a very common one too. But notice that there are other ones that are interesting here too, things like standard deviation and variance. Those are functions that take multiple values and boil it down to one. Or percentile, like you could do median as a percentile, or you could do top 10% or something like this. We need to be careful about these. So these are kind of, we need to be careful, and we'll show why in a little bit about why looking at average GDP in this particular case may be a little bit problematic. We'll talk more about it. But the point being that we change level of detail by adding fields to our visualization, or our table in this case. The more and more detailed fields we have featured in either rows or in columns or in detail, or basically in any of our design elements or shelves, the finer the level of detail, and the fewer rows will be used to compute each one of the cells or each one of the marks in the visualization. As I remove fields from the row shelf or from detail or any of the other pieces here, each one of my fields or each one of my marks and my visualization is computed using more and more and more rows. So we'll dive more into this. In fact, we need to dive into both actual visualizations and see how that works, but then also how do we actually be more mindful in choosing these aggregation functions and doing that correctly. But all of that coming up in future videos.